Welcome to the office. I want to introduce you to our rectangular coordinate system in 3 dimensions. So of course, the XY plane, the coordinate plane, you're likely familiar with, or at least I hope you are. Definitely want to be familiar with that. So here we want to talk about the 3-dimensional coordinate system. For the 3-dimensional coordinate system, of course, we're going to still have X and Y, but it's going to be oriented just a little bit differently. So, right, if we have the coordinate, the regular coordinate plane, we usually think of it as X and Y. Uh, Nope. And what we're going to do here is we're going to say that X and Y we still want, but it's actually going to be arranged a bit differently. So I have X and Y, so you think of it like I can extend these, and I'm just looking at this plane on an angle. And then we're introducing this third dimension, Z. Okay, so X, Y, Z. This follows what we call the right-hand rule. Right-hand rule. And the right-hand rule simply says that if your thumb is pointing in the positive Z direction, then when you curl your fingers closed, right, so if you go from an open hand with your thumb pointing up to a closed hand with your thumb pointing up, your fingers are curling from the positive x-axis to the positive y-axis, okay, following the right-hand rule there. If I wanted to plot a point, let's say I wanted to plot the point 1, 2, 3, we want to recognize that much like this was x, y in our coordinate plane, we have x, y, z here in our rectangular 3-dimensional coordinates. So I can plot, let's see here, 1, 2, 3, just give out a few marks here on each. 1, 2, 3, that looks pretty good. So I've got here 1, 2, 3. So 1 along the x-axis, then reaching out by 2 along the y-axis. So out by 1 onto the x-axis, out by 2 onto the y-axis, and then up by 3 on the z-axis. So going all the way up. Now I'm traveling up parallel to this. So about 1, 2, 3. If I draw this line here, it should extend from 3. Right? So 1, 2, 3. So that's the point 1, 2, 3. So that's relatively basic, not super complicated. If we wanted to, we can, of course, take a look at computer-generated coordinate systems, which would be very nice. We can use GeoGebra to do that. There are other online graphing calculators, but GeoGebra here actually has a 3-dimensional calculator, and I'm not sure that all others do. So GeoGebra, this works really well for. We're going to learn a little bit, of course, throughout the section, but we want to be familiar with, well, let's see, what does it look like for x to be greater than 0, for example. If I did that, that gives me all of this. Interesting. It just kind of gives a grid on the, let's see if you can see it. There's an X there, so that must be the positive X-axis. So our usual orientation is going to be positive X, positive Y, positive Z here. And that looks good. So what if we do, um, let's see what happens if I said X squared plus, oh, gotta push the arrow key to get out of the exponent there. X squared plus Y squared. Ooh, that's interesting. But let's say that this is equal to, I don't know, pick your favorite perfect square. So 5. This gives us a circle. X squared plus y squared is 5, but since there's no designation for what z must be, we actually end up with this circle being represented repeatedly, right, stacking on top of one another for each z value to give us this infinite cylinder. Can't see it from above because it's going to be that circle, of course. So, lines themselves and points don't have a dimension, so you wouldn't actually see them if you just had right, that perspective. So anyway, so it's kind of an introduction to what the x YZ coordinate system looks like. That's all that we were really looking for here to start. So thank you for your time and your attention. Let's take a look at just some basic computations in our following videos. See you shortly.